The final demonstration to do with resonance for today is to look at what happens when we force an oscillator, like a mass on a spring, to oscillate at different frequencies. We put a little driver underneath it that's going to influence its motion. So this oscillator here has a natural frequency of vibration of 1 hertz. That depends on the mass of the object and the spring constant of the spring that it is attached to. So if I let this oscillate, if I just displace it a bit and let it go, it's going to oscillate at that 1 hertz and nothing terribly exciting is going to happen. I've turned down damping so I don't have any frictional effects. If I turn on my driver at a frequency that's different from its natural frequency of oscillation, the base of this thing starts to vibrate and I get a sort of awkward motion. If I reset this so you can see that motion without my initial pull, I put this back on at 3. I don't get a lot of vibration. The bottom is oscillating at 3 hertz and not much is happening with this mass because I'm trying to force it to oscillate at a frequency that's not its natural frequency. If though I change the driver to be at the natural frequency of that oscillator, I get some very surprising results. Almost right away, this amplitude starts to build. This is excessively constructive. The analogy that I think of sometimes is trying to force it to do something that it naturally very much wants to do, and that is personifying it a bit. But imagine someone's trying to make you do something that you really, really want to do. No problem. If someone's trying to force you to do something you don't want to do, there's that awkwardness. So the simulation has broken down here, and that the mass is going beneath the layer of the, or beneath the level of the driver. So we'll reset that. It's also easy to see the difference here if I change the number of resonators. So I'm going to put 3 of them in here. The first one has a natural frequency of vibration of 1 hertz. Second one is 1.5, and the third one is 2. So if I turn this on, say to 2 hertz, I have that bit of awkwardness from number 1 and number 2. Number 2 is oscillating a little better. It's closer to its natural driving frequency, and 3 is just going all over the place. I'm going to turn up damping just to bring it back down. If I then change this to 1.5 hertz and turn off damping, that middle one is going to be displaying resonance and will have its amplitude grow very, very quickly. And then I could do the same thing if I go down to 1 hertz.